All right, let's continue on with our discussion about deflections. So let's look at ceiling and partitions. Well, here's the design guide number 3 criteria, and that's all we've really been talking about so far. So, but what about the building code? Well, the building code has its own criteria, and the building code is not optional. We have to follow that criteria. Um, you can see there's a lot of similarities between these two tables, but there are some differences. Um, let's set a baseline first. So supporting non-plaster ceilings is drywall, and also with other brittle finishes is also talking about drywall. All right. So then there's these superscripts in the code. Superscript F says, hey, you can multiply your wind by 0.42. Well, in the previous example, we talked about where that came from. And the example I came up with, it was 0.44, but very similar. This is a conversion from LRFD to ASD and converting from a 50-year wind to a 10-year wind. And then the superscript D and G. So D has to do with dead for creep susceptible materials such as wood and concrete. But then there's this superscript G, which says for steel members, dead load shall be taken as 0. And that's because there's no creep in steel. All right. Well, let's look at a couple of the differences. So both of these are the same member, supporting a non-plastered ceiling, say a roof member. Uh, the design guide number 3 has a deflection of 240 and the code has 240, but the case says half live load where the code says full live load. Well, the code controls, so we're going to use that. And then for floor beams, the design guide number 3 says deflection of L over 360 or 1 inch maximum, but there's no such criteria in the IBC. It says we're going to look at live load. No, we're not going to take into account dead load. And yeah, so 2 different criteria. You really should hit both. So let's just do an example. If we have a steel floor beam with a gypsum board ceiling, design guide number 3 suggests a dead load case with L over 360 or less than 1 inch. And IBC requires an alive load case with L over 360. The dead plus live case of 240 won't control because, dead is 0. So that last column on the right is just going to go away. And then we can't forget about limiting our deflections to, what our metal connectors can handle. All right. So with all that said, there's a lot of criteria there put out by the design guide and the code, but the commercial software doesn't really capture it very well. So down here at the bottom, you'll see a total load of dead plus live, say, of L over 180. Well, there is no such criteria in either one of those two references. And then there's your live load. So if you do an optimize or an auto select, it's not going to do that deflection of 1 inch, and it's not going to take into effect that, hey, your metal connector might only be able to suck up 3/4 of an inch. So because of that, you really have to pay attention to what the commercial software is spitting out. Now here's a RAM structural system. Its defaults are very similar to EnterCalc, right? I have the one on the right says perimeter. I put that in manually, but you have to pay attention that the commercial softwares, the defaults, don't hit all the criteria exactly correct. Let's talk about equipment for a minute here. Bar grading and steel plate. McNichols, which they're a manufacturer of metal grading, recommends a deflection of 1/4 inch or less under a uniform live load of 100 psf to provide pedestrian comfort. So, yeah, I mean, if you're walking on a steel plate or bar grading and that thing starts to buckle or make sounds underneath your feet, I think you're going to be uncomfortable. So they're just suggesting a 1/4 inch or less. Elevators have a drift of H over 500. So one of the things the wood industry is really pushing, like, let's get rid of the masonry on projects and let's go with wood shafts. That's all well and good, But without masonry stair shafts and elevator shafts, it may be difficult to achieve that H over 500 with the amount of openings that architects like to put in there, and then the mechanical equipment also needs openings. So you got to pay attention that H over 500 can be limiting on wood. Let's talk about camber for a minute. Don't camber when, and this all comes from AISC recommendations, when the beams are less than 24 foot long. Now the jig that they put things in can only handle, you can't do short members, right? So beams that have web thicknesses less than or equal to quarter of an inch on spandrel beams. So this is exterior beams or interior beams. Maybe on the interior you have like a stair opening and there's a spandrel that crosses the middle. You don't want to put camber on those. Interior girders are okay, but if the size gets too big, around 27 inches, then it needs a special jig. It can be done, but you want to check your local supplier. Um, 27 inches is about the time you need to ask, hey, can I do anything bigger than this? Beams and moment frames, beams with braces framing into them, like a K brace or whatever. You can't just, there is no deflection on braced frames, right? So beams shallower than 14 inches, a W14 class is okay. Beams with cantilevers, beams with non-uniform cross sections, beams with significant non-symmetric loading, beams subject to significant twist. All right. So how much load should you camber a beam for? Well, 80% of the dead load is what they recommend. RAM structural system defaults need some editing. So we just said it comes in there. Well, what spans? Well, the default here is 20 or 0. And then we just got finished saying that, hey, 24 is the minimum that you want to go. And then depths less than what? It doesn't say. So we want to say 14 inches, but then, some 14-inch sections are like 13 point, whatever. And so you want to pay attention to these depths. Now, what about equipment mezzanines without oscillating equipment, right? They have no drywall underneath them. And what kind of deflection criteria are we going to use on those? Well, the Rack Manufacturers Institute says, hey, let's take a live load deflection not greater than 240 and a total deflection not more than 180. And then, interestingly enough, like what's the horizontal deflection? And notice the title here, equipment mezzanine. People can get up there. There's, if you're in an interior mezzanine and there's no wind load to speak of, and in low seismic zones, what are you going to do to put like a horizontal kind of constraint on this whole system? Well, the Rack Manufacturers Institute says, hey, let's apply a 350-pound side force. Okay. So if you take that 350-pound side force, and that's, of course, if you're loading it with a fork truck or something, then you have to design it in the way it says here. And then, interestingly enough, the 1997 UBC had a deflection limit of H over 278, where you didn't have to do a P delta check. So one school of thought is to take that that's not arbitrary, but the 350-pound point load, and whatever deflection you get, hold that to a deflection of 278. That's a way of going. At least it's something, right? It's somewhere to start. But I recommend a horizontal drift limit of H over 200 under this load case of dead plus omega, where omega is 1,000 pounds. And honestly, this is just something I produced. It is based on experience. If you do the former criteria with the 350 divided by with the H over 278 criteria, sometimes people say, "Hey, this thing's kind of wiggly." So if you put 1,000 pounds on these mezzanines, these little mezzanines, that takes that wiggle out of there, and then you get less complaints. But with that said, you've got to use engineering judgment. Sometimes there's other things going on. It's really, really small, and you don't really care about that wiggle. So use your judgment. Questions?